All right, students, let's start with our first topic, Introduction to Spatial Database Systems. So, what exactly is a spatial database system? Well, think of it this way. A regular database is great at storing things like names, roll numbers, phone numbers, salaries, or dates. But what if I want to store where something is, like the exact spot of our college on a map, the route of the Pune-Mumbai Expressway, or the boundary of Pimpri-Chinchwad City? That's where a spatial database system comes in. A spatial database system is simply a computer system designed to store and manage location-based data. It's different from regular databases because it doesn't just store what the data is, it also stores where it is and sometimes what shape it has. What kind of data do we store? In spatial databases, we deal with spatial data. That's data related to maps, places, or shapes. It can be of three types. First one is points, small locations like where a tree is or where your home is marked on Google Maps. Second one is lines, paths like roads, railway tracks, or rivers. And third is areas, polygons, bigger regions with boundaries like a lake, a park, or an entire city. So, unlike a simple student database, here we can model the real world. Why are spatial databases important? They're useful in so many fields. For example, GIS, Geographic Information Systems, to create and analyze maps. Urban planning, planning new roads, metro lines, or city layouts. Navigation apps, Google Maps, Ola, Uber, all powered by spatial data. Environment and disaster management, predicting flood zones, tracking forest fires, etc. What kind of questions can we ask? The real magic is in the queries. A spatial database can answer questions like, which buildings are near the river? Which roads pass through Pimpri-Chinchwad? How far is PCCOE from Pune Railway Station? Now, if we stored this data in a normal database, answering these would be very slow. That's why spatial databases use special indexing methods like R-trees and quad trees to find locations faster. Some popular spatial databases. In practice, we have several systems that support spatial features. PostGIS, extension of Postgres. Oracle Spatial, MySQL Spatial extensions. These tools are widely used in industry whenever maps and location data come into play. Real-life examples. Let's make this even more relatable. Smartphone map app. Suppose you open Google Maps and search for the nearest hospital. The app looks into its spatial database of hospitals. It calculates which ones are closest to your current GPS location, and it shows you a list on the map and even gives you directions. All of that happens because of spatial queries. Finding all hospitals within 5 kilometers. Imagine you want to see every hospital within 5 kilometers of your house. The spatial database calculates the distance between your home and all stored hospitals. It quickly filters out only those inside that 5-kilometer radius. Behind the scenes, data structures like R-trees and quad trees are making these searches efficient. Types of queries supported. Spatial databases don't just handle select star from students. They can answer queries like, what is near this location? Does this area overlap with another? What is the distance between 2 points? That's why they're so powerful and so widely used today. So, to wrap up this topic, a spatial database system is all about storing, managing, and querying data that has a location and shape. It is the backbone of maps, GPS, city planning, disaster management, and so many real-world applications.